With all the components soldered and all the holes filled except for these two itsy bitsy through holes here and these 4 unused programming holes. With all the holes filled, we should have this left. The integrated circuits, 2 bags of hardware, the power cable, and the case components. I bought 2 of these kits. Yesterday I inventoried the contents of a kit in order to develop a bill of materials, and I found in that kit a third 22 picofarad capacitor. It appears to be extraneous, but that's 2 kits. Now I bought them from the same seller. 2 kits with a spare 22 picofarad capacitor. Take off the paper seal. The majority of kits like this that employ these multi-pin integrated circuits, inserting the chip into the socket causes 90% of the problems. We'll start with a small chip just because we have to start somewhere. These legs are slightly splayed outward. It's imperative that they be perfectly parallel. See the difference? This one looks like it could move in a little. The idea is to insert the chip so that the legs fit in the depressed area between the spring and the backing plate. They should not be touching the plastic. The end of the socket, you remember, had a divot or a notch in it that corresponds to the silk screen, and it would correspond to a matching symbol on the integrated circuit. So number 1, make sure you don't reverse this. Number 2, make sure all pins fit properly. Then it's just a matter of seating it. Just push it in. A lot of times a pin will be bent outward. Well, that's easy to see. It's a matter of pulling this chip back out and bending it in. But almost invisible is when one of these pins folds under the chip. Doesn't go into the metallic part of the socket. If you do have to take a chip out, use a flat screwdriver and get in there and lift it out, moving each end a little bit. Don't want to cock it too much, you end up bending the pins. I found that rocking on a surface will almost always work. I found this on eBay. I don't know where. I don't even remember how much. presto, the pins are now bent to a proper positioning. Make sure the divot is lined up, or the notch. I spend a little too much time bending this so it looks through the hole, because the case, when we take the paper off, is clear. So that probably was overkill. If there's some holes that are not popped out, just push them out. Then remove the protective paper. Try not to scratch it up too badly. If it begins to rip, turn it around and take it the other way. So 4 screws are installed, just sticking up through the holes, the round holes. Break apart these 4 spacers and put them on top of the screws. Doesn't matter which way around it goes. Just sit it on top. Screw the 4 brass, copper colored, whatever, spacers down. And proceed to tighten them up. Once that's done, plug the display in. There we go. Here's the side plate. The legs go downward and orient it so the big hole is over the power connector, like this. Now, I made a bad choice when I installed the thermistor and the CAD cell, so I'm going to correct that now with a little bit of wire bending. The CAD cell, or the lighting the light sensitive merely needs to look through the clear plastic case, while the thermistor should project flush with the surface of the rear panel. Then we can install the side plates. At this juncture, I guess, well, we'll go ahead and put the hooks on. So that gives us all four sides. Now we take the black screws. At this point, I'm going to take some pieces of electrical tape. Now, if you have good steady hands, you might be able to get away doing this differently. The idea is to get the top put on with all the spacers intact. You may have a better way to do it. Maybe you can just carefully put the spacers down, lay the top on, put the screws in. I'm too shaky for that. Now, if you haven't done it earlier, would be a good time to remove this plastic protective sheet. USB bicoaxial power jack. Plug that in. Now we need a 5-volt USB power supply that does not come with the kit. Something like this. There we go. I think I would first adjust this potentiometer until I can see something. You see, if I turn it up too far, I get the individual block letters. There we go. So we just back it off until that fades. And there we go. Now this is, in theory, the temperature. This should change brightness as the room darkens. All that's left now is to program it. You see it's already counting. I don't know what the A means, nor do I know what the 1 means. At this point, you need to get a 10-year-old or a teenager to figure out what these programming keys do. That stopped the clock and allows me to set I do know what month it is. I assume we can here we can switch from 12 to 24-hour time of day. Temperature in Fahrenheit or Celsius. At this point, I turn it over to you. There we go. Except I don't know how to turn the alarm off. Unless one of these buttons is the on-off alarm. There are setting instructions with the clock. Well, I hope you enjoyed this series. Come back for the next one. Thank you.